Within a teamwork, each designer is responsible for a certain part of the vehicle. This stage is after completing the final shape of the concept. After completing the exterior and the interior, then creating the blueprint from the concept design. Each designer shall have a blueprint for certain part to build. This is the ideal approach of design for manufacturing. In our case, we're still developing the shape of our concept. After completing the concept design, we are not going to create blueprints for the design inside 3ds Max. Since Autodesk decided that 3ds Max should not have these capabilities. If you want to go further, you can use other packages, such as Fusion 360, and, if you do not prefer to work on a cloud-based software, you can use Inventor. There, you can build your design and create the schematics for manufacturing. There are other packages, but, since I am using Autodesk products, I am not going to mention them. This introduction is important because I will be creating parts without blueprints, and this is not the right way of designing, especially when you are trying to mimic something real. We're still developing the concept shape, and then, if we want to go further, we should do the final design in the proper package or software for the manufacturing purpose. However, our designing plans will end after completing the concept shape with all the required accessories as a game asset. We are going to focus on the artistic side in this chapter. The eyes can tell too much about a person. You just need to know how to read them. Good day everyone and welcome to this tutorial. We can use the free-form read topology tools to create the base for this headlight. However, I cannot read anything, actually, from the current headlight design, and it does not reflect the sport look of the concept. It has been more than 20 years. Let's bring this concept to the future. Time to do some upgrade. There will be a lot of minor details that we need to do. Even with the clipping enabled in the active viewport, the default camera will not provide us the comfort field of view during the modeling. We need to set up our scene to overcome this limitation. As you can see, I can scale the part and finish the modeling, then rescale it again to its default location. If we can somehow manage to do this automatically, that would be a great idea. We are going to need 4 frames from the track bar. You can enable the track bar from Customize, then Show UI. The slide bar is more than enough, since we are not doing any animations. Open the time configuration, and set the length to 4. We actually need 1 frame, but just in case. Right-click on the time slide bar to add key. Make sure that all the modifying options are enabled. On frame 0, press Auto key, then press the key icon to add key. I am going to use frame 0 to adjust the overall shape of the headlight design. And on frame 1, I am going to scale the mesh to the scale that will allow us to model minor details. Release the Auto key after scaling the mesh. use your designing skills to create the base for the headlight and its components. You can draw sketches of the shape you want to design, and this is actually how they do the designs in the manufacturing companies. They start by drawing the sketches for the concept design that they want to achieve, then they develop it to its final shape. I am going to draw the shape I am shooting for with the polygons. I ended doing this design. Once you are done with that satisfying design, you need to connect all components together and correct the topology if needed. This is not going to be a modeling tutorial, however, I am going to give you a brief and two methods to achieve cuts on a surface. Method 1 is by using the cut tool, and this will give you clean result. This is the method I prefer to use. Here, I am creating a supportive loop around each component. I need to make a hole on the surface for it. The right way is to create the supportive loop first, then use the Insert tool to create the hole. I am using constraint to edge and face while moving these vertices. You need to correct the topology after adding those supportive loops. Now, you can use the Insert tool to create the required holes on the surface. You can add supportive loops to correct the topology. Those we can remove later, in the cleaning process, after committing to the Turbo Smooth modifier. If precision is what you seek, you need to use method 2. This is going to be a nightmare. In method 2, I am going to use the Boolean to make those supportive loops around each component. Here, I am trying to control the radius length for each supportive loop around the headlight components, which is something hard to achieve inside 3ds Max. Because we do not have the right tools to control the measures to achieve precision. Precision is something you need to achieve when developing a design for manufacturing, and for that kind of precision, you need to use the proper package, as we mentioned early. Remove all modifiers above the object before applying Boolean. We successfully created the required supportive loops, and we need to remove all the leftover vertices that we do not need. Choose wisely the suitable tool for the job. Finally, I am using the loop Regularize script to create a circle surface with equal distributed vertices over its radius. We still can develop this part by using this method, but it is not the right approach. We can attach the headlight components and connect their loops, or leave them unconnected. In all cases, we still need those supportive loops around those cylinder shapes, or holes, to achieve this shadows effect, as you might notice.